All right, so now it says we want to find equations of exponential functions if we're given two data points. Then after those two data points, we have to convert it into that exponential model. So what we're going to have is if one of the data points is the form 0a, like where intercepts is, that we knew that that point there was a. And so then we could say, okay, well, f of x is equal to a b to the x. So we just plug that a right here in that, and we're done. Then a is their initial value. Now using a, we're going to substitute the second point into the equation of this and solve for b. Okay, that's the easy one. Now what happens is, what if neither of the data points has the form a comma 0? So maybe it's going to be 1 comma 1 and 3 comma 5 or something like that. Well, then what happens? Well, we're going to have to substitute both points into two different equations of this form. And so we'll have, this is our y, remember, and that's our x. So we plug it in, and then we're going to have to solve that system of equations to find our a and b. Now, whether we did step A or step 1 or step 2, then when we get done, we want to write the final answer in this format. Okay, so what we're going to do is we're going to do a couple of examples. Some of them might be, like number 1 where we have A given. Some might like be number 2 where you have to go ahead and plug both of them into this format, and we'll have, maybe that was 1 equals A B to the 1, and the other one was 5 equals A B to the 3, and then we have to solve that system of equations and get our a and b out. So sometimes we have a little bit more work. Sometimes it's just a one or two steps we have to do instead of multiple. All right. So we want to write the exponential function in the form f of x equals a b to the x. So wolf population is growing exponentially, hence this format. In 2009, 129 wolves were counted. By 2013, the population had reached 236 wolves. What 2 points can be used to derive an exponential equation modeling this system? So that's our first one. And then write the equations representing the population in of wolves over time. Well, it says here we started. And so if we start with this number, what we're going to say is, oh, that is times 0, t0 equals, well, that's going to be 0. And this is going to be our y, which is going to be the number of wolves. And so that's going to be that. And so we could have a point 0, 129. Okay, and that y didn't look very good there, but that's okay. And then it says by 2013, then the population had reached 236 wolves. So 2011 to 2013, that's going to be 2 years, and it went up to 236 wolves. Okay. So what do we know? Well, we know A is equal to 129. And so now what we can do is we can say, okay, well, if this is our other equation, we can say 236 equals A, 129, times B to the X. Well, X was 2. Now we need to solve for B. And so to do that, we divide by 129. So B squared is equal to 236 over 129. How do we solve for b? Well, we take the square root. And when we do this, we're going to take plus or minus the square root of this. But do we have a b being negative? Wouldn't that be kind of not right? So we're just going to take the positive square root. So if we take the positive square root of 236 over 129, we'll have the square root of 236 divided by 129. And what does that equal? Oh, I guess we don't need that. There we go. Delete that. And what does that equal? 1.3526. And so our B is equal to 1.3526. And it really doesn't say how many decimal places to use, so we'll use it all just to be on the safe side. And they say they wanted it as n of t is equal to, well, we knew A was 129. We just found 1.3526, and that's going to be to the x, or t rather. I guess we're using t again. So that's what we would have for our exponential growth. Now we could also say it's 129 times 1.3526 to the t. I've seen it both ways. Either way is correct. It doesn't matter as far as how you do it. And so I would go with that. Now, since they have the parentheses here, probably the latter one would be the actual one to use. Okay. Now it says, given the 2 points, now this time we don't have, 0 comma a, so we actually have to solve this system of equations. And so what we're going to do is we're just going to plug both of these sets into our function, basically our y equals ab to the x, okay? So let's do this first one. Y is 3 equals ab to the 1. Our second one is 4.5 equals ab to the 2. Okay. Now, if we think about this one, we could solve this for A or for B. If we solved it for A equals what? Well, it's just going to be 3 divided by B. Okay. Now, what can we do? Well, we can plug that in here and we can solve. So 4.5 equals 3 over B times B squared. Well, can we simplify that? Well, sure. Now I'm going to change colors here so I can see it. Well, this B is going to cancel one of those B's, and that gives me, oops, 4.5 equals 3B. Well, I can solve that. I divide both sides by 3, and B is equal to, that's going to be 1.5. Okay. Now, what does that give me? Well, now I can plug that in here, it looks like. And so A is going to then be 3 divided by 1.5. Well, if I move the decimal here, 1 and 1 here, 30 divided by 15 is 2. And if you could see 3 divided by 1.5 is 2 as well, that's fine. But some people like to kind of get rid of those decimals. Now I can write a function, and it doesn't say what I can use, so I'm going to use f of x equals, well, it's going to be a, well, yeah, I know it's a, it's going to be 2 times b was 1.5, and if I put the parentheses like they've been saying, and then to the x, that would be my function I would use in this case. Okay, so again, we just had to plug it in, get our two equations, and then simplify from there and work our way down until we got our final function. All right, let's stop there and I'll come back for more.